Resistance genes and fungicides are all that protect the cereal grains industry from up to $1 billion in estimated crop losses annually from stripe rust. Stem and leaf rust have affected cereal crops in Australia for 200 years. In comparison, stripe rust arrived more recently, thought to have entered the country via Victoria.
The initial incursion into Australia occurred in 1979, and then we had the second incursion in 2002 from Western Australia. And what that did was it spread across the country, and then we had a series of mutations from that 2002 epidemic in the eastern states.
These newer pathotypes overcame a number of important resistance genes, including YR17. What makes YR17 so important to plant breeders is that it's classified as a seedling resistance gene, so the resistance switches on early and is maintained throughout all growth stages.
In the eastern states, we had virulence for YR17 detected in 2006, and it spread across the eastern states, and yet the YR17 resistance gene is still highly effective and is now used across about 70% of Western Australia's area to protect it from stripe rust. That's actually a key risk if we get an independent mutation occurring in Western Australia, or if someone walks the rust over from east to west, then that's going to cause huge problems for management of stripe rust in Western Australia.
In Australia, there's an early warning system to help identify incursions of new rust strains or variations in known pathotypes. It's the Cereal Rust Survey, run by the Plant Breeding Institute. The Grains Research and Development Corporation is the main funder. Growers submit samples of rust from their paddocks, and the Institute exposes commercial and pre-release cereal varieties to the collected rust spores.
So if a new resistance gene is actually identified and put into a new wheat variety, we then have to incorporate that in our tests in identifying the strains so that we can monitor the virulence on that particular resistance gene. Now, if we happen to find a new strain that can overcome that resistance gene, then we're able to put out an early warning to farmers, if they're growing a variety carrying that gene, to say, please monitor your crop. This variety is now susceptible, and if you find any rust, then please do send us some samples.
In countries where rust surveys haven't been well supported, cereal crops are at greater risk from the incursion of a new rust strain.
In recent times in the UK, they've had, in the last 5 years, let's say, a new incursion across from coming across Europe and probably originally from the Himalayas into their wheat growing regions. And they've been playing catch up, trying to get a decent insight into what's been going on with pathogen mutations occurring in their country. And that's come from an historically under-resourced survey that's been in that country.
Fortunately for grain growers, stripe rust is one of the few diseases in cereals where there are management options.
So we've got a lot of resistance genes that are effective against stripe rust in the eastern states of Australia, so we've got a lot of genes that breeders can be incorporating into varieties. But we also have fungicides that are highly effective for controlling stripe rust.
Having a fungicide program in place is especially recommended for anyone growing a more susceptible variety or one that relies on adult plant resistance. But growers in the West are encouraged to send rust samples immediately they find any in their crop.
Because that reliance on YR17 to protect the WA wheat crop is a strength because YR17 is a good resistance gene, but it's a weakness when everyone is relying on the one single resistance gene to protect their entire state's wheat production.